Hello there. In this video, we are going to cover efficient imports in pygame. Now, this isn't the flashiest of topics, but if you want to create a larger project, this kind of knowledge is absolutely essential. We are going to work with some kind of project folder. In just a second, we're going to work inside of main, but for now, don't worry about it. What is much more important is that we are looking at graphics, because in there, we have lots of images in various folders. Some are quite easy, like this candle is just a PNG file. But then we also have the player, for example, where we have lots of subfolders and then animations inside of it. Also, we have tile maps and we have to separate the images, or we have objects where we want to import a whole folder. All of this we want to import. And you could do all of that manually, but that would be a nightmare to work with, and well, it would take you forever and it wouldn't be particularly reliable. Let me actually demonstrate. Here we have an incredibly simple pygame setup. This is just about the simplest kind of setup you can actually have. If I run it, we have a plain black window. And to go over it really quickly, we start with pygame, and then we are also importing exit, simply to exit the program at the end. After that, we are initializing pygame, and then we are creating a display surface with the dimensions of 1280 by 720. This is the width and the height of the window. After that, we are creating a game loop. In there, we are checking for one event, and that is when the player tries to close the window. If that is the case, we want to quit pygame and then exit the rest of the code. After that, we are filling the entire surface with a black color, and finally, we are updating everything so we get a proper frame. If none of that made sense to you, check out my introduction to pygame. This one goes into much more detail. But anyway, what I want to do for now is to import a graphic. And usually the way you would approach something like that, you would assign it to a variable, let's call it a surface, and then you would use pygame.image.load. And in there, you specify a path. And let me bring in the folder. Let's say for now, I want to go to graphics and then import this candle. For that, we have to go to graphics and then candle.png, which means we want to go to graphics and then candle.png. Also, what is really important in pygame is that you want to convert alpha, whatever image you're importing. With that line, pygame is going to run significantly faster. And once you have that, you can run the code and you have imported a surface. You can't see it right now, but that we can change by blitting it. All we have to do is get the display surface and then blit with the surface and the position, let's say 100 and 200. If I now run the code, we have the candle. That looks pretty good. However, this kind of approach has two major downsides. The first one is quite minor, but the second one we can't really get around. Problem number one is that the path to the image should be dynamically generated. For example, some operating systems use a forward slash while others use a backward slash. And if you have a hard-coded path like we are using right now, this might cause an error. And this is an issue that you ideally want to avoid as much as possible, which Python can do quite easily. So this first issue isn't that much of a big deal. However, the second point we can't get around, and that is that this kind of importing system is terrible for importing multiple files. Just to demonstrate, this is the project folder again. And for example, if we wanted to import all of the files inside of the objects folder, we would have to call pygame.image.load 6 times, once for each of these images. The same we would have to do for each folder inside of the player, and every time we have to write a new path. And that's just kind of annoying. We would end up with hundreds of lines of code simply for the imports. And every time we wanted to add another folder, we would have to write even more. And that just sucks. Also, sometimes you have a tile map, where you have one tile map, and this one is quite small. Let me zoom in. If we simply imported something like this, we wouldn't really have anything useful. So the import function should also be able to extract one part of this image. Also a fairly common thing you encounter in pygame, or in literally any kind of game development. And to make all of that work, we want to write a couple of functions that simplify and automate this process. All of those functions should be inside of a new Python file. So new And then we have to save this file under some name. I usually call it support.py. You could also call it importer.py or something like that. It really doesn't matter. Now that we have that, first of all, in there, we have to import pygame. That way, we get access to all of the functionality. Then we can create the functions. The first one will be the simplest one, and this is simply to import an image. And the way I want this function to work is that later on, you can simply add the different folders you want to go through. For example, in our case, we want to go to graphics, then to player, for example, and separate all of them with a comma. After all of that, you should also be able to specify if there are alpha values and what kind of file format we have. Quite a bit, but for now, let's simply add a path in there that we want to go through. And before we do anything, let's print that path. With that, inside of main.py, I want from support, import, everything. And then, instead of importing all of this, I want to call the function we have just created, import image. And then the way I want to use this is I want to go to graphics, and then I want to import candle. And important for this one, we do not want to add .jpg. We simply want to have the name of the file, and then Python takes care of the file format. Now this at the moment is not going to work because we have 2 arguments and we only have a single parameter. Although what Python can do is unwrapping. So if I run all of this now, we are getting an error because Surface at the moment doesn't have any kind of image. So this line causes an error, but that is not a problem. We don't want to do that right now anyway. Let's try it again now. And inside of the function, this line here is going to print all of the arguments we are getting. That way we can add as many arguments as we want, and Python handles all of this internally. After we have that, we want to specify if we have alpha values on the image or not. And this by default is usually the case. So I want to have a default argument for true. And finally, I want to specify the file format. And this by default should be PNG because this is what you use most of the time. With that, we already have quite a bit. So we would get a path, we would get an alpha value, and we would get the format. If I now run main.py, we're getting quite a few things. And that we can use. Most importantly for now, we have to create a full path. And this is the path from the current Python file to the actual image. Now for this one, we do have to be careful because this one we want to generate dynamically via Python. That way we would, for example, take care of forward or backward slashes depending on the operating system. And for this kind of thing, Python has an inbuilt function that you import with from or s.path, and you want to import the join method. All that join really does. Let me actually use it. You want to call it, and then you want to specify a folder. All of those have to be comma separated. For example, I want to go to graphics, and then I want to go to candle.png. If we now print the full path, and we don't need the other stuff anymore, what we're getting is this kind of thing, graphics/candle.png. And depending on your operating system, this slash might be forwards or backwards. Python simply gives you the correct one, which means now we have to figure out how to connect this join method to our path. And we couldn't simply pass the path in here right away. If I now run main.py, we're getting an error because the join method is expecting a string, bytes, or OS path-like object, not a tuple. So the issue at the moment is that with this unpacking, we are taking all of these arguments and putting them into a tuple, which the join method cannot work with. To overcome that, we want to unpack it once again. That way, all of this works just fine. Basically, we are turning this tuple into separate arguments. The end result is going to be a working path, although this is not exactly what we need, because there is the file ending that we're not accounting for. To get that, we want to add an f string where we want to add dot and then the format we are specifying. If I now run main.py again, this is looking much better. We are getting the proper path to this file. And that is actually all we needed. Now that we have that, we can create a surface. And that we still do with pygame.image.load. Although now we have the full path. And this surface we want to return at the end of the function, which means back inside of main.py, after we are running this function, we should have something inside of the surface. And as a consequence, we should be able to call display surface.blit with the surface in some kind of position. Let's go with 0 and 0. If I now run this, we have the candle back. Except now, we are doing all of this a bit more elegantly. This function is a bit easier to work with, and it's also going to work much more reliably on different operating systems. However, we are missing one thing. We are not converting the image once we are importing it. The way around that is we want to convert alpha all of this, but only if alpha is true, i.e. the image we are importing has alpha values. If that is not the case, so else, we still want to load all of this. I can actually copy the entire line, except now we simply want to call convert. Now, if I run all of this, we are still going to have the same result, but the image is now much more efficient and pygame would run faster. And that covers the first function. Now we can import images much better. Now, that being said, all of this isn't that impressive. We're not doing anything too fancy. So next up, we can create a function to import a folder. And once again, I simply want to specify a path in there, and the user should be able to enter basically anything. So we want to unpack this path right away. And I suppose what we want to import inside of our graphics, we want to import item collect. This is a very basic animation. All of this we want to import with a single function call. Ultimately, what we are going to do, we are going to store all of this inside of a list. And then at the end of the function, we are going to return this list. Now we have to figure out how to access a folder from inside of Python. And for that, once again, we have an inbuilt Python method that is incredibly useful. That we get with from OS, and we want to import the walk function. The way you are supposed to use that is with a for loop. Let's say for now, for test in then walk, and now we need a file path, which we also want to generate via the join method. So in there, we want to add the path. And then we want to print whatever we are getting. After that, inside of main.py, I want to create a surface list, which should get the values from import folder. And the path we want to specify is we want to go to graphics, and then in there, we want to open the folder called item_collect. So item_collect. And now if I run all of this, we get one list with 3 values. And all of that we are getting because of this print statement. The first value that we are getting is the folder we are currently in. The second value is the names of all of the subfolders. At the moment, this list is empty because there are no subfolders inside of this folder. And finally, the item we actually care about is a list with 3 entries. 0, 1, and 2 PNG. Those are the names of the files inside of this folder. So if I open all of this, we get 0, 1, and 2, and all of those are PNG files. These are the files we want to use to create a path once again. So ultimately, what you have to understand is that at the moment, we simply have a couple of names, or rather strings. We have a name of a file and the folder we are in, and all of that we have to stitch together to get a proper folder path, like we have done for import image, although now it's going to get a bit more complex. Not that much though. First of all, we want to unpack all of this inside of the for loop. The first value we get in the for loop is the folder path. Then we get subfolders, and finally we get, let's call this one image names. And what we actually care about is the image names, because in there we can run another for loop. Let's call it for image_name in image_names. And now we can print the image name, and let's see what we get. We get 0, 1, and 2 PNG. That's a really good start. Although we don't just want the name of the file, we want the path to that file. And that we want to store in a variable, let's call it full path. This, once again, we want to create via the join method. And now our life is going to become a bit easier because Python, from the walk method, already gives us the folder we are in. Which means we want to have the folder path and then get the image name. And after we have that, we can print the full path, and we should be getting a path to all of the files inside of this folder. After that, once again, we can actually import a surface, which we do with pygame.image.load. We want to pass in the full path, and for this one, I usually run convert alpha all the time. When you're importing multiple images, it's almost guaranteed that you have some kind of alpha values. Although you could be a bit more flexible here and do something like we have done up there, but for this kind of function, I don't think you need it most of the time. But anyway, all we have to do now is get our frames and then append the surface, and after that, we are done. Back inside of main.py, I can print the surface list. And let's see what we get. We are getting a list with a bunch of surfaces. That's pretty cool. That is exactly what I was looking for. The way you would use that inside of an actual game is you would get the surface list and then use indexing to get one of the surfaces. For example, 0 would give us the first frame, then we could use 1 for the second one, and so on. However, there's going to be one issue that we do need to work on. At the moment, we are not sorting any of these images. Now, for Windows, this usually isn't a problem because Windows goes with the names from 0 and then upwards. So 0 comes first, then 1, and then 2. But this isn't always the case, and once again, depending on the operating system, this might be different. macOS, for example, might sort files in a different way compared to Windows, and we want to be explicit here, especially when it comes to animation. We always want to start from 0 and then go upwards. If you mess up the order of the files, you would break any kind of animation. Which means, when we are importing all of this, we want to sort the image names, which we can do via the sorted function. For that, we will need a key, which usually is a lambda function where you have to add one parameter. Let's call this one name. And basically what I want to do, once again, let me show the folder. We want to sort all of these images by their name. So 0 comes first, then 1, and then 2. However, at the moment, name would be a string, which Python cannot sort. And as an example, one name that we might have right now could be the string 1.png. And essentially what we want to do is to get rid of the .png and then isolate the 1 and turn it into an integer, which fortunately is very easily done. We want to create an integer and we want to get the name and split it after we have a dot. This split method splits a string along a certain point, in our case the dot, and the return value would be a tuple with the values from the start to the end, wherever we get the separation. Now, in our case, we are always going to get two values. First of all, the name of the file, and then the file ending. So for example, the string 1.png would become a tuple with 1 and the string png. In our case, the only thing that we really care about is the first value, which means I want to get rid of these nodes. I want to use indexing to only get the first value. And now if I run main.py, we get the same outcome. However, now this function is going to sort the images, and that way for an animation, we always start from the lowest to the highest values, at least as long as we are using numbers. However, that's not always the case. For example, if we tried to import the objects with that, it wouldn't work because you couldn't sort these kind of names. Also, the names are really important. So when we're importing all of these files, we want to retain the names, which at the moment doesn't happen. So once again, if I print the surface list, we simply have a list with surfaces. We do not know the names of these files, which sometimes you really want to have. To handle all of that, I want to create a third function. Let's call this one import folder, but now we want to do all of this in a dictionary. Although, once again, we simply want to specify a path and then get some return values. Once again, though, we want to create a local variable, which is going to be the frames. And now we want to have a dictionary. The key for this dictionary would be the name of the file, and the value would be the surface that we have imported. And after we have finished the function, we want to return these frames. For this function, once again, we have to use the walk method. As a matter of fact, I can actually copy it because we are going to do basically the same thing. After that, we want to run the same for loop once again. In fact, I can copy this one as well. For image name in image names. Although now we are not going to sort the image names like we have done in import folder. After that, once again, we want to create a full path. And this full path, we are going to create exactly like we have done before. So I will do it like that. And after that, we want to create a surface, which once again, we also have done inside of import folder. Import folder dict and import folder are fairly similar functions. However, there are some differences. And the most important one is coming up now. Since we now have a dictionary, when we are assigning the surface to this dictionary, we have to specify a keyword. So we want to get the frames, and then we want to specify a keyword, and only then can we assign the surface as the value. So what's the keyword going to be? And well, basically what I want to do, I want to get the image name and then split it once again wherever we have a dot, and then get the first value. That way, let me open the folder again. If we, for example, have bgpalm1, which is a PNG file, inside of pygame, we will get bgpalm1.png. And with the split method, we're getting rid of the .png. For the name inside of pygame, we don't really care about the file ending. But other than that, we have finished another function, which means now inside of main.py, we can create a serve dictionary and then use the import folder dictionary function. For this one, the path should be graphics, and then we want to go to objects. And after that, I want to print the surface dictionary, run the code, and we are printing a dictionary where we have a key, so the name of the file, and the associated value is a surface. The way you would use that one inside of an actual game is, once again, you would use the blit method and then use the surface dictionary we have just created along with the name of a file. For example, one file in there would be ship. If I now run this, we have a ship. And now I hope you can see how useful these kind of functions are. Because instead of calling the import 6 times, we are using one import to get all of this. And also, it's more reliable across different operating systems, and it's generally much, much cleaner. But we can actually push this system quite a bit more, because next up, I want to create another function that I'm going to call import subfolders, which once again just wants to have a path argument. At the moment, once again, I want to open the graphics folder. We can import the item collect folder and the objects folder. However, the player is quite a bit more complex because in there we have a whole bunch of subfolders. And inside of each subfolder, we have frames for an animation. Okay, bad example, but for the idle folder, we have 5 frames inside of a subfolder, and we want to import the entire player folder and store it inside of a dictionary. Essentially, what I want to have. Once again, I want to create frames, which I will return at the end. So return frames. This is going to be a dictionary. The key will be the folder name, and the associated value will be a list of surfaces. So in there we would have surface 1, surface 2, surface 3, and so on. To do one example, if we look at the player, one key could, for example, be idle, and then inside of this folder, we have a list with all of these surfaces. For now, though, I want to have no values inside of the dictionary. To make this one work again, we have to use the walk method another time. Let me actually copy it from import folder dictionary and then also minimize everything else so we can focus on one thing at a time. So with this for loop, we can loop over a folder. But for this one, it's going to be a bit different. As a matter of fact, inside of main.py, I want to create, let's call this one the surf folder, which we create with import subfolders. We want to go to graphics, and in there, we want to go to the player. Now that I have that, back in support.py, I don't want to do the unpacking in the for loop right away. Instead, I simply want to get a basic overview of what we are getting returned. And let me print this test. If I now run main.py, you can see that we are getting slightly inconsistent data. The first argument is the folder we are in. The second value we are getting returned is a list with all of the subfolders. Once again, if I open the folder, you can compare it. We have air attack, fall, hit, and so on. All of these are the subfolders. Finally, at the end, we have all of the actual images inside of this folder. At the moment, there are none, so this list is empty. Afterwards, the walk method goes through all of the subfolders. So we start with air attack, then attack, fall, hit, and so on. In all of those, we don't have subfolders, but we do have actual files. Now, this isn't the perfect setup because the data is inconsistent. The first item is always going to be a little bit different compared to what we get afterwards. Can be a very easy source of mistakes, do be careful here. But in our case, that isn't too much of an issue, because I only really care about the first item we are getting. I want to get all of the subfolders. To indicate that in the code, I want to add an underscore for the folder name. Then I want to get the subfolders, and then I'm going to add a double underscore to indicate that I also don't care about the file names. All I really care about are the subfolders. If I print those, run main.py, we are getting all of the subfolders and then a whole bunch of empty lists, which we can safely ignore. They're not going to cause an issue. Because essentially what I am going to do, I'm going to check if we have subfolders. And if that is the case, I want to run a for loop for subfolder in subfolders. If that is the case, let me print the subfolder. And if I now run main.py, we simply get all of the subfolders inside of this main folder. That's a really good start. On top of that, what we can now also do is reuse the import folder function. Basically, all that I want to do is I want to get my frames again, and then we need a key, which in my case is simply going to be the subfolder. And the associated value is going to be all of the images inside of this folder, which we get with import folder. The only thing that we have to specify is the folder path, which we can do by unpacking the path that we are getting right at the beginning from the arguments. Although this would be the path to the parent folder. So to that, we want to add the subfolder. And after we have that, we are done. This was actually it. If I now go back to main.py and print the surface folder, and I can run all of this, and we are getting a pretty massive dictionary. We have a name of the folder, air attack in this case, and then a list of surfaces. In this particular case, this would be one surface, then we have another surface, and a third surface. After that, we have another key value pair. This one is called attack, and once again, we have a list with surfaces. And that's basically all we need. If you have a character animation that you want to import, this function is incredibly powerful. And once again, inside of an actual game, you would first of all have to get the surface folder, and then, first of all, you want to specify the key, so the folder we have imported. Let's say in this case, this one could be idle. All of that would return a list of surfaces, and from these surfaces, you would want to pick one via indexing. Let's go with 0, and now if I run this, we have the pirate. That looks pretty good. And that way, with a single import line, we have imported a whole bunch of surfaces. Incredibly powerful. Now, we are nearly done. There's just one more case that we have to cover. And that is, if I open the graphics folder one more time, we have a tile map. And in there, we have a completely separate system. Because now we want to import one image, but then only pick one specific item from it. Let's say, for example, we want to import this little guy. Or to be a bit more specific, we want to import the entire thing and then separate it via columns and rows. So we would have 3 rows, and then I believe it's 9 columns in total. That is a number we should be able to specify. To make all of that work, I want to create a new function. Let's call it import tile map. And this one is going to be quite a bit different compared to what we have done before. The way we want to approach this one is we want to specify how many columns we have, how many rows we have, and then we want to specify the path. That being said though, once again, we want to specify a dictionary that at the end of the function should be returned. And let's call it inside of main.py, so we get some kind of value. I suppose we can call this one serve tiles, which we are getting with import tile map. And then we have to specify the amount of columns, the amount of rows, and the path. I know that we have 9 columns, 3 rows, and the folder path is graphics. Then we have tile maps, and the file we want to import is called tile map. With that, back inside of support, I can print the columns, I can print the rows, and I can print the path. Let's try all of that, and we get 9, 3, and a tuple with the file path. Cool. First of all then, we have to actually import the entire image, which we now can do quite easily, because we have an import image function, the one we have created earlier. All we have to do is to unpack the path we have gotten via the arguments. That way, we are getting this image. Now we have to figure out how to pick individual parts from that. So basically, we want to loop over all of this, first via the columns, and then via the rows. And then always cut out one specific part and store it inside of a key value pair. For that, first of all, we will need to know how wide each of these cells are and how tall they are, which we can get by getting the entire width of the surface and then dividing that by the amount of columns that we have. I am assuming that they all have the same size, which they usually do inside of a tile map. But depending on your specific circumstances, you might have to experiment just a little bit. All that we want to do is specify a cell width, which is going to be the surface, and then we want to get the width of the entire surface, and then divide all of this by the amount of columns that we have. And that's pretty much it. This isn't too difficult. After we have that, I also want to get the cell height. And I can do all of that on a single line of code, because it's fairly straightforward. To get the height of the cell, we want to get the entirety of the surface, and then get the height of the whole surface, which we can then divide by the number of rows. Now we know how large each cell is going to be. After that, we want to loop over the entire image. We want to first of all go for col in range cols. After that, we want to go for row in range rows. Finally then, we want to create a cutout rectangle, which we do with pygame.rect. In there, we have to specify the left, the top, the width, and the height. And once again, basically what we are doing is on the first for loop, this one, we are looking at all of the columns. Then on the second for loop, we are looking at all of the rows. And once we have all of that, we want to create a cutout rectangle, which would be a rectangle in the right position with the right size. And for that, we have to specify the top left, then the width and the height. The width and the height we already have. That's the cell width and cell height we just created. Although we do have to get the top left. That part is still fairly easy though. We want to get the column for the left side and then multiply it with the cell width. The same we want to do for the top. This one is going to be the row multiplied with the cell height. And then the width is going to be the cell width and the height is going to be the cell height. With that, we have a rectangle that covers the exact spot that we want to cut out. Now, basically how cutting out in pygame is going to work. We first of all have to create a new surface with the right size, which we do with pygame.surface. And in there, we want to get the cell width and the cell height. On this cutout surface, we are going to paste, or rather blit, the cutout from the surface, so the main surface we have imported. Basically, we want to get the cutout surface and then use the blit method. We want to get the parent surface, and for the position, we want to get 0 and 0. However, then we want to specify a third argument. And this is the part we actually want to cut out, which is going to be our cutout rectangle. And then with that, we have cut out one part of the surface and placed it on this cutout surface. It's a bit convoluted, but once you get the hang of it, it's not too difficult, I think. But basically now on the cutout surface, we have the actual surface that we want to have. Which means all we have to do is get our frames and then specify some kind of key. In my case, I think the best way to approach this is to have a tuple with the column and the row. That would be the key, and the value would be the cutout surface. After we have all of that, inside of main.py, we should be able to print the surface tiles. If I now run all of this, that looks pretty good. We are getting a dictionary where we have a tuple as the key. And then for each of those keys, we have one surface. And I think the best way to demonstrate that is to actually use it. Inside of the game, I want to get the surface tiles, and then as the key, you want to have a tuple, let's say with 0 and 0. If I now run this, all the way in the top left, we have the surface. Exactly the one that was specified inside of the image. Also, you could change this, for example, to go to, let's say, column 3 and row 1. And I think in there, we have the block that does the smiley thing. And that works pretty well. Although this function isn't done yet. Because if I change the background to gray and run this again, we get the black background color. And that isn't something I want. The issue we have at the moment is that when we are creating a new surface, and if the image we are cutting out from the parent doesn't cover this entire surface, then we get the black background, which wouldn't look very good. The way around that is you first of all want to fill the surface that you want to blit on with a color you know you are not going to use. Most of the time that is a pure green color. This one is quite rare. So now, if I run this, we have a green background color for the tile we have imported. And that looks absolutely horrible. The reason why I'm using this particular color is because on the next line, I'm going to tell this surface to ignore every pixel with this color, which we can do with set_color key, and then specify the green color. If I now run main.py again, we are not getting any black background anymore, or any background whatsoever in general. So what happened here is that we have filled the background of the surface with a color we know is not inside of this surface, and then we have told this surface to ignore all of the pixels with that color. That way, we are removing any kind of background. And that is pretty much it. With that, we have a couple of functions that are pretty useful to import basically any number of surfaces into pygame. And especially if you have a larger project, this kind of functionality is incredibly useful. I hope that was useful, and I'll see you around.